Hello everyone. Let's solve some of the linear algebra questions that are asked in the GATE exam in the previous year. So let's start with the question number 1. Question 1 says the eigenvalue of this matrix, which is 3 cross 3 in dimension, and all entries has 1 1 1 are. Okay, so they are asking the eigenvalue of this matrix. Now here we we have to just simply use the property, the sum of the all three eigenvalues, lambda 1 plus lambda 2 plus lambda 3 will be the trace of this matrix. Let's call it M, and the multiplication of these three numbers gives the determinant of this matrix M. So now here we can easily say that the determinant of this matrix M will be 0 because they have identical rows. Two rows are identical. Sorry, all three rows are identical to each other. So the determinant of this matrix is 0, and the trace of this matrix is just simply the sum of these three entries, which are 1 1 1. So we are getting sum as 3. So let's go by option. So option A gives sum as 1, so option A is not correct one. Option B gives sum 0, B is also wrong. Option C gives sum as 3, and option D also give sum 3. Now move on onto this second property, the multiplication. Now here the determinant equal to 0, so the multiplication of this three number will must give 0. So again option D will be wrong because it gives the multiplication as 1, and we need the multiplication as 0. So only the remaining option is C. So option C correctly describes the three eigenvalue of this 3 cross 3 matrix. So option C is the correct one. Okay, now let's solve question number 2. Question 2 says in a Gauss elimination method for solving the system of linear algebraic equation, triangularization lead to what types of matrix? Okay, so triangularization lead to what kind of matrix? Okay, so in the Gauss elimination, what we are just simply doing, we have here a matrix. Let's assume it 3 cross 3. So we are just simply reducing it into the echelon form. So here we try to make these all entries are 0, this entry, and this entry. If we done this operation uh, to make this entries are 0, then we end up with only these entries which are at this place. So now we can say that it is a nothing but just upper triangular matrix, because all the entries below this leading diagonal will be 0. So thus in the Gauss elimination method we are end up with the upper triangular matrix. So option C is the correct answer for this question. Okay, now let's solve question number 3. Question 3 says a matrix A has a m cross n size. Okay, so let's write this matrix A has an m cross n size, and matrix B has an n cross p size. Okay, so what they're asking, the number of multiplication operation and addition operations needed to calculate the matrix AB. Okay, if we multiply these two matrix, then number of addition and number of multiplication that are required to find the AB matrix. We have to find the AB matrix. So now to find this AB matrix, first of all let's write. We have to write A here because we want to find the AB. So here the we have to write the matrix A, which is m cross n dimension, and here we have to write the matrix B, which is n cross p dimension. Now in the output we get this AB matrix. Now the dimension of this AB matrix is just simply this first element and this last, so we get m cross p. Now to find this AB matrix we have to multiply this first row of this A matrix with this first column. So now here we first find the number of multiplication to find this AB matrix. So here let's it is given that it has uh, n column. So here we have n entries here 1 2 3 4 5 up to n because it has dimension m cross n. So it has n column. So here we have n entries. Now here we also have n. So this entry will multiply with this and give the first multiplication. This entry will again multiply this one and give again one multiplication. So we have done two multiplication. This entry again multiply with this. So again we have done three multiplication. In the same manner, this all n entries are multiplied with this n entry. So we for finding this first element only, because we have to add up this whole multiplication. So here this first row will multiply this with this n element. So we got the n multiplication from this first element. Now in the same order for this second element in this AB matrix, we have to select the this same row, first row and the second column. So now here we again multiply this. We have to multiply this element with this first one, again this second with this one. So now in the same order we again get the n multiplication for this second entry. For third entry also we get the n multiplication. So we have to just multiply this n with p because it has p row. This matrix B has p column, p numbers of column. So we have to multiply this n with p because if one columns give the n number of multiplication, then n columns give the np. Okay. So here we have end up with this first row in this AB. Now move to the second row. The same second row will also give the np multiplication. Second row will also give the np number of multiplication. Third row will also give the np number of multiplication. Fourth row will also give the np number of multiplication. And now how many rows we have in the AB? So we have m rows in this AB. So we have get np multiplication m times. So we have to multiply this np with m. So we have find out the number of multiplication, which is just npm. Okay. So okay, these two option B and C give the number of multiplication as npn and npn. So we have to find the multiplication, and second we have to find the addition operation. So let move to the addition operation. Now here in the addition, uh, just simply first of all we multiply this element with this. Now we have to add this second element in this first one. This one we have to add this third in this element. So here now we have, suppose we have this AB plus BC plus CD. Now we have three entry, but we have only done the two addition. So here it has an n entry because it has n column. It has n entry. It has this matrix B has also n entry in this first column, but the we have to done just simply n minus 1 addition, because one addition is less, because addition is always done between the two individuals. So we are getting n minus 1 addition from this first element. Now we have find out this first. Now for this second, again we have to do n minus 1 addition. Now this third, for this third again we have to do n minus 1 addition. For this element again we have to do n minus 1 element. So we just have to multiply this n minus 1 with the number of column that we are getting in this AB matrix, which are p. So we have multiply this number with p. Now now we have got this first row. Now we move to the second row. For finding the second row, we have to do the this same number of multiplication for this second row. For third row also we have to do this number of addition, n minus 1 times p. For the fourth row again we have to do the same number of addition, and up to we have m rows in this AB. So we have to done this time of this much of addition m times. So multiply it with m. So we have find the number of addition also, which are n minus 1 times p times m. So look at the option. Option C is the correct combination of this number of multiplication, which are npm, and a number of addition, which are n minus 1 times m times p. So option C is the correct number of multiplication and addition required to find this AB matrix. Okay, let's solve question number 4. Question 4 says, let A be an invertible matrix and suppose that the inverse of 7a is, okay, we have given the inverse of this matrix, which is a 7a, and the inverse is given also in the question. So they are asking the matrix A. So first of all, let's write what we have given. We have given the inverse of this 7a. We have, so let's write in this inverse form. So let's write this 2 cross 2 matrix here, which is the inverse of this 7a. Now we have to find the matrix A. So just we have to take the again the inverse of this inverse. So let's write it here. We are going to take the inverse of this inverse matrix again. Here also we have to find the inverse of this matrix. So here we also have to find the inverse. So use the formula 1 upon the determinant of this matrix, because we are finding the inverse of this. So here the determinant will be plus 7 minus 8. So minus 1. Now we have to find the adjoint of this 2 cross 2 matrix. Now remember the shortcut. In the case of 2 cross 2, we have to just flip this diagonal element 1 and minus 7. This minus 7 will goes to there, and this minus 1 will goes to there, and we have to alter the sign of this second diagonal. So first let's do here. We are getting minus 7 here, minus 1 here. We have to alter the sign of these two. We have plus 2, so we have to make it minus 2, and we have here we have to make minus 4. So we have find out the adjoint. Now let multiply this minus 1 uh, inside of this matrix. So what we are getting here, just simply all entries will be plus after the multiplication with minus 1. So now we have here what we are getting on the left hand side. We are taking the inverse of inverse. So simply we get this initial matrix, which is 7a. So we get the value of 7a, which is 7, 2, 4, 1. But we want this matrix A. So let's just simply divide both the side by 7. So we are here on the left hand side we are getting A. Now on the right hand side here 7 by 7. So 1 here, 2 divided by 7 here, 4 divided by 7 here, 1 divided 7. So we have find out this matrix A. So look at the option. Option B is the correctly describe the matrix A. So option B is the right answer. Okay, let's solve question number 5. Question 5 says the solution to the equations. Okay, we have three equation, and we have only two variable x and y, and they are asking the value of this unknown alpha such that the solution of this system will exist. So, so we have to find the value of this unknown alpha. So here we have to first of all write in this matrix form. So 2, 3. So here it is basically over determined system, because we have a more number of equation than the variable. We have only two variable, and we got three equation. So it is an over determined system. Here we have 1 for alpha. So here what we have to do, just let form first of all augmented matrix from this matrix. So here we are getting 2, 3, 1, 1, minus 1, 4, alpha. Here it is alpha. So now we have to do some row operation to reduce it into echelon form. So let's subtract this second row 2 times from this first row. So r1 minus 2 times r2 will gives new r1, and let's also subtract 4 times this second row from this last row. So R3 minus 4 times R2 will gives new R3. So after these two operation, what we are getting simply just here we are getting a 0 as an entry because we got minus 2 from this second row. So here we are getting 0. Here we have plus 3 and we are getting plus 2 from this second row. So we are getting plus 5. Now here we have got minus 8 plus 1 already there. So we get minus 7. Second row will remain as it is. Now in the last row again we are getting 0 here. Here we have got plus 4 minus 1. So we got minus 3. Now here we have to multiply it with minus 4. So we got alpha minus 16. Okay, so we have to reduce this third row further. So let's divide this first row by 5 to make this entry 1, and after that we have to multiply with plus 3 and add in this third row. So let's write it here. Let's R1 divide by 5 will gives new R1. So after that we are get simply here 0, here we get 1, here minus 7 by 5, here our integer remain as it is. Now we have to multiply this first row with 3 and add in this third row. So let's do it. R3 plus 3 times R1 will gives new R3. So after this operation, what we are getting, first row remain as it is, nothing is changed, minus 7 by 5. The second row also remain as it is. Now in the third row we have already 0 here. Here we have minus 3. We got plus 3 from this first row. So we got 0. Now this alpha minus 16 remain as it is. Now minus we have to multiply this entry with 3 and add in this. So here we are getting uh, 3 times 7 by 5 because it has minus sign. So we have to put it here. So uh, now if we have a solution for this system, then the rank of this matrix, let's call it A, and this whole matrix as an augmented with including this part, the rank is same. If this entry, the last entry, I'm talking about this entry, if this entry will 0, then and then the rank of this matrix and rank of this whole augmented matrix will be the exactly same. So we have to make this entry equal to 0 to find the solution for this system. So let's equate this entry equal to 0. So here alpha minus 16 minus 7 multiplied with 3. So minus we are getting 21 by 5 equal to 0. So here we can find the value of alpha. Simply just here we are getting 16 multiply with 5. So 80. We have to add this 21. So we are getting 101 divided by 5. So we got the value of alpha for the system of this three equation. Now check the option. Okay, none of the option is given in this term. So we have to choose the option D. None of the above. D is the correct option for this question. Okay, now let's solve question number 6. Question number 6 asking the multiplication of this two matrix L and M. We have given M also. We have also given L and M. So let's simply do the matrix multiplication. First of all, let's write L here. So L has entry like this. Now let's write M here, which is through 3, 2, 0, 1. Now let's do the multiplication. So here we have to multiply this first row with this first column. respectively with this element. So we have to multiply this 2 with 3. So we are getting 6, plus from here we are getting 0. Simply we are getting here 6. Now for this second element, we have to multiply this first row with this column. So we have to multiply this 2 with this 2. So we are getting 4. From here we are getting 1. So we have to add these two value. So we get 5. Now for this element, we have to select this second row and this first column. So this 3 will multiply with this 3. So we are getting 9. And we have to add this multiplication of this both. So we are here getting 0. And we have to add plus 9. So we are getting only plus 9. Now for this fourth entry, we have to multiply this second row with this second column. So here 3 multiply with 2, 6, plus 2 multiply with 2. So we are getting 8. So now you can directly see option C is the only has this 4 entry, as we are got by this multiplication. So only the option C is the correct one. Now we can select and go forward. But here let's do also the remaining entries. So here we are getting 12, and here we are getting 8 plus 5 80. Sorry, uh, 8 plus 5, okay, 13, not 18. So that's it. Option C is the correct multiplication of these two vectors, sorry, matrix. Okay, let's solve question number 7. Question 7 says if A transpose A inverse are equal, where A is a real symmetric, then A is, okay, we have given condition that the transpose of matrix, it is exactly same as the inverse of this matrix. Now recall the properties of orthogonal matrix. If we multiply any matrix with its transpose and in the output we get the identity matrix, then we call it an orthogonal matrix. Now here, if we multiply this equation with A inverse, so what we are getting here, A inverse times A transpose equal to A inverse on the right hand side. So here we reduce it into identity. So simply write A transpose, and we have right hand side A inverse. So we got this property for the orthogonal vector, and that is given in the question. So we can say that the A is must be orthogonal to satisfy this property. So option B is the correct answer. Okay, now let's solve question number 8. Question 8 says the eigenvalue of square symmetric matrices are always, okay. So symmetric matrix, first of all, if we taking the transpose of any matrix, and after taking the transpose we get the same matrix, then we call it an symmetric matrix. Symmetric matrix. Now the symmetric matrix has another property is that its eigenvalue are always real. So remember this property for the symmetrics matrix. So option B is the correct one for the eigenvalue, because it has a property that the all the eigenvalue of symmetric matrix are always real. So option B is the right answer. Okay, let's solve question number 9. Question 9 says if A is a real square matrix, then A times A transpose is, okay. So they are asking about the multiplication of this A times A transpose. So option is given. It is a non-singular, unsymmetric, always symmetric, sometimes symmetric. So let's assume some general vector. So here I am assuming 2 cross 2. So let's call it A, B, C, and D, because it is easier to do multiplication with this 2 cross 2 matrix. Now I have to take the transpose because I have to multiply this matrix with its transpose, and it is given that A is a real square matrix. So we have chosen the square matrix and all entries are real. So let's take the transpose. So here we are getting just simply A, B, C, and D. Now let's do the multiplication of these two matrix. So here we have to multiply this A with A, so A square. We have to add this multiplication, so B square. Now for this second entry we have to multiply this A with C, so we are getting A times C plus B times D. Now the remaining entry, here we have to multiply this C with A. So again we get A times C plus this B with D. So BD. Now the last entry will, this C will multiply with this C. So we are getting C square here, and here we are getting D square. Now you can compare. The end is here on the opposite side of the diagonal. Here AC plus BD. Here you also get AC plus BC. So it is the properties of symmetric matrix. You can also take the transpose of this matrix. Let's take the transpose of this matrix. So what we are getting after taking the transpose, A square plus B square, AC plus BC, BD, AC plus BD, here C square plus D square. It is the exactly same as this matrix. A transpose is just simply as A, and it is the properties of symmetric matrix. You can also tell it by just observing this matrix, because this entry and this entry are exactly the same. Then we call it an symmetric matrix. So now we can also check about the 3 cross 3 matrix. Let's do it also. So let's assume general 3 cross 3 matrix in terms of A, B, C. Now we have to multiply this matrix with the transpose of this matrix. So let's take the transpose. So here we get, so now we have to do the multiplication. So let's do it here. So this A will multiply with A. So we are getting A square. This B multiply with B. So we are getting B square. And the last we are getting C square. Now the second entry, we are getting here A. We have to multiply with B. So we are getting AB plus BE plus CF. Now if I want to find this entry, so I have to multiply this row with this first column. So we are getting here again, sorry, here it is in D, not B. So let's correct it. Here we have D, here we have D. So here also we have D. So correct, let's erase it. We have here A times D. Now let's find this second element also. So here we have to multiply this D with A. So again we get AD, plus we have to add this E with B. So BE. Now again F with C. So FC. Now you can see this element and this element are exactly same. Now in the same order we also get this element and this element will also same. Now this element and this will also the exactly same. So it is the properties of again the symmetric matrix, and here we get the diagonal. So you can do by finding all other entries, you still get the symmetric matrix for any order in general n cross n. So the only correct statement is always symmetric. Option C is the correct one. Okay, let's move on the question number 10. Question 10 says if a matrix algebra S times A is equal to A times T, where A, S and T are the matrices of appropriate order, because we have to do the multiplication, so they are in the appropriate order. Then okay, S equal to T implies, okay, this if this is happen S equal to T, then out of this four condition, which condition uh, must be satisfied this matrix A to equate this S and T. So okay, let's write it here. We have given A times S equal to A times T. Now we have to reduce this into S equal to T. So of course we have to remove this matrix A. We cannot just simply cancel it. For removing this matrix A, we have to multiply this matrix with A inverse and also this matrix with inverse of this matrix A. So let's multiply this matrix, sorry, left hand side with A inverse. So here we are getting A inverse A times S. Here also multiply with A inverse. So here, so now we can reduce it into identity. This is also reduced into identity because A times A inverse gives the identity matrix. So we end up with S equal to T. So okay, we have find out this condition. But here, when A inverse is possible, if we write the equation of A inverse, it is nothing but simply just 1 upon the determinant of this matrix A times the adjoint of A. Now, adjoint of any matrix is always determined by 2 to 3 steps. And but here, the if we want to find the inverse, then the matrix A must be non-singular. That means the determinant must be non-zero because we have to divide this adjoint by the determinant. If the determinant of any matrix is zero, that means if matrix is singular, then we cannot find inverse because we have end up in this denominator with zero. So the condition must be satisfied by this matrix A to find its inverse. That it must be a non-singular. In the other word, it has a non-zero determinant. Then and then we can remove this A from this equation by multiplying with this equation both the side with A inverse. So the necessary condition to imply S equal to T is this condition B. A is a non-singular matrix. Okay. So correct condition for this equality is just A is a non-singular matrix. So that's it, and thanks for watching this video.